Today we're going to be looking at some representations of information called Venn diagrams and also working with two-way tables. So our learning intention is to use Venn diagrams and two-way tables to represent outcomes for experiments that include overlapping categories and also to calculate their probabilities. So by the end of this lesson, you should be able to construct a Venn diagram or a two-way table to represent a certain amount of information. Determine probabilities based on that information. And as an extension, there's actually a bit extra, particularly for those who are planning on studying advanced and extension maths next year, which is using some formal notation to write out what's shown in a Venn diagram or a two-way table. So this extension section I will do as a separate video. So if you are doing advanced or extension 1 maths next year, I would highly recommend you watch the second video before completing the questions. So if you're doing standard, this first video is enough for you, and the questions are at the end of this section. If you are doing advanced or extension, I would recommend that you watch the next video, and then your set of questions will be at the end of that video. So when we're looking at probability, sometimes we'll look at experiments that have overlapping categories of information. So we can use a Venn diagram, which is your circle diagram, so the one right here, or a two-way table to represent that information. So students have the option to study two languages, French and Japanese. The Venn diagram shows the subject studied by the students. So we've got French, so we've got this circle here, so everyone inside of that circle studies French. We've got the circle here, everyone in there studies Japanese, and then we've got a box on the outside, so if anyone's in the box, okay, they're part of this class, but then they don't study French and they don't study Japanese either. So what we want to first do is convert this into a two-way table. So these two methods are interchangeable. Sometimes it's easier to represent information in a Venn diagram, and it's easier to read that way. Sometimes it's easier to read in a two-way table. So it's really up to you how you want to represent your information, usually. So if we're looking at a two-way table, we've got our two categories. So French and Japanese are the two categories. So we can either have someone who studies French or doesn't study French, studies Japanese or doesn't study Japanese. So in this first box here, that's going to comprise of people who study French and also study Japanese. And that's going to be these 5 people in the overlap. So that means there's 5 people who study both. If we come over here, we've got the people who study Japanese, but they don't study French. So that means they study Japanese, but not French. So what we're doing is we're looking at this section of the Venn diagram. And we can see we've got 13 people here. So if we wanted to add them up, the total number of people who study Japanese is 18. And you can see if you look at the circle, if you add up everyone in the circle, it is 18. The next box here, someone who doesn't study Japanese but studies French. So that means we're looking at the French, taking out the Japanese. So we're looking at this section here. And we can see we've got 10 people. And if I want someone who doesn't study Japanese and doesn't study French, well, I'm looking at the outside. And we've got 2 people there. So the people who don't study Japanese, we've got 12 of them. And then what we can do is we can add the columns. So the number of people who study French is 15. The number of people who don't study French is also 15. And we can see we've got a total of 30 people in this class. So part B, a student is chosen at random. What is the probability that the student, firstly, studies French? So what we want to look at is this section here. So the number of students who study French is 15 out of 30. So the probability for French is 15 out of 30, which is a half. Part 2, what is the probability that the person doesn't study French? So remember the word doesn't means that we want to find a complement, but we can already see half of the people study French, so the probability of not F, okay, or we could write that as probability F with the line on top. That's going to be also a half. Part 3, what is the probability that a student studies French and Japanese? So we want someone who studies both languages, and that's those 5 people out of 30. So probability of French and Japanese is 5 out of 30. Well, that will give us 1 over 6. And the last one, studies French or Japanese. Now that's a really important word, okay? So when we're talking about or, it means that they study French, or they study Japanese, or they can also study both, okay? So what we need to do is we need to work out how many people altogether. For this sort of question, it's actually a lot easier to use the Venn diagram. So we're looking at everyone inside of these 2 circles. That's really what we're looking at. So we want the 10, the 5, and the 13. So when we add all that together, so probability French or Japanese is going to be 28 out of 30. When we simplify that, that's 14 out of 15. So the word or means that we want everyone who satisfies at least one of those criteria. When we're looking at the word and, okay, well, I use the symbol. When we're looking at and, it means that they need to satisfy both of them at the same time. So that's why it's only that overlap section. All right, now we're going to look at a question where you need to work out the Venn diagram yourself. So a survey of 60 people found that 42 people like golf, 36 people like tennis, and 5 people like neither sport. So these are the important numbers. Draw a Venn diagram showing the information. So I've already started your Venn diagram for you. So we're going to have people who like golf, people who like tennis. We know that 5 people don't like either of them, so we can put the 5 people on the outside straight away. Now what we know is if I add together everyone who enjoys golf, that's going to equal to a total of 42 people. Okay, but the 42 is this section, including the overlap as well. If we look at the people who like tennis, of this circle, we have a total of 36 people, okay? But again, it's going to include this overlap. So if I add together these numbers, I'm going to have added together this number here and this one number here. If I add the 36, then it's this one and this one. So what's going to happen is that middle bit's going to be double counted. So to work out what the overlap is, what we're going to do is add all of these numbers together, and then whatever the value is greater than 60 is going to be the overlap, because that's going to be the number of people who have been double counted. So if I've got 42, 36, and the 5, when I add those together, 6 and 5, I've got 83. So we've got 23 people that have been double counted, which means that the overlap is going to contain 23 people. Now we know in the golf section, we've got 42 people altogether. So if 23 of the people are here, then the number left over is going to be 19. Likewise, if I'm looking at the tennis, we know there's 36 people altogether, the 23 plus this number. So the number of people who only like tennis is going to be 13. So to work out your overlap, you're looking at how many people have been double counted. So part B, find the number of people who like golf only. So now we've got our diagram, we can read it straight off here. So we've got 19 people who only like golf because they're in this section, okay, by themselves. How many people like both sports? We're looking at the overlap, which is 23. And then the last one likes golf or tennis. That's going to be everyone inside of those circles. So we're going to add these numbers together. So 19, 23, and 13. That's going to give us 55 people. Or another way we could have worked it out is the complement, so the opposite of the 5. So we had 60 people altogether. If 5 people don't like any sports, then 55 people must like one or the other. Last section, so one person is chosen at random from this group of people. Find the following probability. So the probability that the person likes tennis. So if they like tennis, we want everyone who's inside of there. So that's 36 out of the total of 60 people. And we should always simplify these, and it's 3 out of 5. The probability they like tennis and golf, you're looking at the overlap, so that's 23 out of 60. That can't be simplified. The probability they like tennis or golf, so we want tennis or golf, that's this number here. Okay, they like golf or tennis. So that's going to be 55 out of 60. Simplify that, 11 out of 12. And the last one, the probability they don't like tennis and they don't like golf, well, that's those 5 people out here. So that's going to be 5 out of 60, or that's 1 out of 12. So if you're okay with that, these are the questions for anyone who wants to stop here. If you want to give the extension bit a go, watch the next video, and then the questions that I'd like you to do are at the end of that. So if you are doing the extension bit, don't do the standard questions because there will be overlaps in the questions. Highly recommend, if you're comfortable with Venn diagrams, give question 17 a go. That's actually a 3-way Venn diagram, so that's a nice challenge, a nice different way of thinking sort of question that you might like to have a go at.